Okay, in this short video, I just wanted to go over an example of one way that you could wire the circuit up. One of the things that I found is really helpful, and I think I mentioned this before, but making sure that you kind of check off your connections as you go. And I usually start with the power pins first. So, and I'll zoom in on the circuit in a moment. But so for example, for IC2, which is the 4017, the pins are located here. When I make that connection, for example, going from pin 16 up to the 5 volts on the top, I'm going to put a line through that, or you can use a highlighter. But you want to keep track of all the connections you've made. If you aren't really kind of systematic with this, especially with a little bit more complicated circuit like this, you can run into problems pretty quickly. So again, I usually will start with the power pins first, make sure they're connected. And the 9 volts in this case, I've connected the 9 volts on the top to the strip, the bus strip, and the ground on the bottom. And let me kind of jump into a closer view of the breadboard to show you how this is done. Now this is just one example. It's not the cleanest wiring of the circuit, but it gives you at least one way to kind of visualize how you could do this. So there are basically a couple of options. You can either use the regular jumper wires like this one that's shown here, or you have a number of different wire pieces that are spooled together, solid core wire, different colors. And if you want to use that and kind of cut the wires to length, I'd recommend that may be a better option, just because as you can see, it starts to get pretty messy. And it's hard to avoid it not being messy like this. A couple of things that are important, and so like if you see the 555 part of the circuit over here, it's pretty clean the way it's wired up. And I think I showed an example of that in the video. For the diodes, one of the things that's really important is you got to make sure none of these wires hit each other. If any of them touch, you can potentially damage the circuit or it may not work. So the way this is wired is that each of these outputs from the 4017 are going to go to each one of these different diodes, and then the diodes are going to bus together at these points, and I'll show you again on the schematic where that is. And then what I used here is this bus connection for all the negative leads of the LEDs, and then you used a resistor to connect that to ground. So let's take a look at the schematic how that's laid out, and I'll bring the drawing back again. Now, one of the things again that's very important to keep track of, the physical package of IC2, the layout does not follow the actual pinout on the schematic. And again, that's because the inputs are typically shown on the left, outputs on the right, ground and positive are on the top and the bottom. Now this looks a little bit different simply because the power pins are separated, and that's something that's common in these schematics. If we look down here, this is where the power pins are located. The reason that's done are a couple of reasons. You might wonder, well, why didn't they just add them to the top and the bottom of the package? Well, if you have a lot of these ICs, it can really get into the way of a lot of the connections, and it can kind of get messy. And if we have a lot of these integrated circuits, we can simply bring a lot of those power pins together, bus them together, and kind of simplify the way the power is shown. So again, if we look at the actual IC package, if this is pin 1, 8, 9, and 16, it simply does not follow this convention at all. We've got pin 14 in the middle, 13 and 15 over here. But the reason they do that, again, is that the inputs, the way that they're arranged is more for function rather than the way that the device is laid out. So you just got to be careful with that. So point being, for example, if this doesn't make sense to you, if we have pins 1, 2, and 3 here on the device, pin 3 is the one up here that's connected to the diode and then to the LED. So the diodes that are used are these little glass diodes. The part number is 1N4148. You can actually see it's printed on there. It's pretty small. The LEDs you have in your package, I think, are probably the larger ones, which are the T1 3/4 package. These are the little ones, the T1 package. The ones I think you have are these larger ones. So you'll probably have to space things out a little bit more. But what I wanted to show you is, for example, where D2, in this case, is connected to D10. And how I did that in this case is I would wire these diodes up together. So D2 and D10 might be connected here and here. Then I bus the leads and connect one side to the LED there. That's basically what we're seeing. And again, it's a little hard to kind of visualize the difference between the schematic and the board layout. The important thing is that you're following the pin numbers. That's the most critical thing. So again, I'd recommend for the outputs, for example, when you connect pin 3 pin 3 on the IC here to D1, is you'd mark that as you made that connection to that diode, okay, which is this diode in the end here. And you want to lay these out in sequence because the LEDs actually flash in sequence. Now, I don't want this to be a spoiler, but this is kind of like what, if the circuit's wired correctly, it should run like this. Now, it looks like it's going out of sequence, and that's because the refresh rate on the display is a little bit slow, so it's a little bit out of sync. But you get the idea there. And by changing this capacitor, the C1 value, the electrolytic capacitor here, you can change that flash rate if you want. And we'll look later at ways you can do that with a switch or a potentiometer to change the speed. So, again, this looks a little bit messy, a little hard to follow. But if you're slow and careful with the layout, you shouldn't have any problems with it.